Hey everyone, welcome back, and today let's solve Leetcode problem 1636 titled Sort Array by Increasing Frequency. So we're given an array of integers nums, and we have to sort the array in increasing order based on the frequency of the values. And if multiple values have the same frequency, we want to sort them in decreasing or descending order. And we have to return or output that sorted array based on their frequencies. So in example 1, we have nums to be an input array of 1, 1, 2, 2, 2, 3. And since 3 has the lowest number of occurrences or the lowest frequency in this input, that would be the initial value of our output array. And now 1 is the next element that has the next lowest frequency, which in this case is going to be 2. And so we'd output those two 1s to be next or adjacent to the 3. And since 2 has the largest frequency or number of occurrences, which in this case is going to be 3, we'd output those 3 2's to be the very last numbers of our output. Okay? So applying that same logic to examples 2 and 3, we'd output 1 3 3 2 2 and 5 -1 4 4 -6 -6 1 1 1. So something important to note here is that for example 3, 5 and -1 both have a frequency of 1, so they are considered to be tied. So how do we decide which number would come first? Now, we'd sort them by descending order as the problem says right here. So since 5 is greater than -1, it has the larger value and the same frequency, we'd put that first before the -1, and then the -1 would be right after the 5. And since 4, 4 and -6, -6 have the same frequency, since 4 is larger than -6, 4 would come next, and then -6. And since, of course, 1 is completely independent, it doesn't tie with anyone because it simply has the only largest frequency of 3. Those 3 1s would be at the end of the array. Okay? So the larger the element has of a frequency, the more to the end of the array it goes. So I'll give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a bit. Okay, so before we actually start coding, I'd like to just give a quick note here that honestly, I think this should be a medium problem. Although it probably will be one of the rather somewhat easier medium problems, I don't think easy is the right tag or label for this problem because it can get pretty tough to implement, right? Even though the solution is pretty easy to see and it's pretty intuitive, actually coding up and implementing that solution is a lot harder than most of you guys probably think. And since we're doing this in Python, it won't seem too bad because we're going to use some very simple sorting functions and operations, but for other languages, it might get a lot more complex. For example, some lower level languages like C++ or even Java to a certain extent. So the way we're going to do this is, since we're actually dealing with the frequencies of every single element in this input, the best and most efficient thing that we can do is simply store the counter of the input array nums in, let's just call it a count variable. So for any of you guys who don't know what a counter actually is a counter is essentially a hash map that relates or stores maps every single element in our input or any iterable that we pass in with its corresponding frequency. Okay, so if we were to take example 1, for example, if we actually got the counter of this nums input array, we'd store a 1 with a key value pair of 2 because 1 has a frequency of 2. We'd store a 2 with a key value pair of 3 because 2 has an occurrence of 3 or frequency of 3 within this input or iterable. And we'd store 3 with a key value pair of 1 because it has a frequency of only 1. And in fact, to better visualize how that would work as a hash map, I'll simply print out count so you guys can see how that actually would work. So if I were to submit this, of course this wouldn't actually be accepted. But you can see it that we actually get outputted a hash map with every single element in our iterable or input array nums in this case with its corresponding frequency. Okay, so now that we have that out of the way, let's just go ahead and define a helper function. I'm just going to call this literally just sorter because I don't think sorter is a keyword in Python or really any programming language that I can think of. But feel free to correct me if I'm wrong for any of you guys who know otherwise, but I don't think it is. So for our parameter, we're just going to take one number. I'll literally just call it number. And we're going to sort that number by the return value of the count at that indice number. Okay? And essentially what this does is we're simply taking a parameter number in the sorter helper function, and we're returning every single number in the iterable based on the count at that indice number, or basically its frequency in the counter. That's why we use the counter for. So we're actually going to use nums.sort, or basically sort the nums input array using the .sort method. And for our key, we'll pass in that sorter function. However, there is actually an issue with this code, right? So if I were to return nums, this wouldn't actually be accepted. It would be accepted by like a good amount of test cases, I believe, right? Yeah, 55. But this wouldn't actually be sorted because this doesn't account for when we actually have ties in our frequencies of different elements, right? In this case, we have our output to be 1, 2, 3, 3, 2. So for starters, we have 1 in the right spot because 1 has the least frequency, and so that's going to be at the beginning of our output array. So that's right. But there's an issue here. Since this code doesn't account for ties, these 2 and 3s are in the wrong place. Okay? Our expected output would be the 3, 3 to come first, and then the 2, 2s to come after. But in this case, it's just a big mix-up of 2, 2s being at the edges, and the 3, 3s being squashed in the middle of them too, which of course is wrong. And the reason why this doesn't work is, again, this doesn't take account for ties or potential elements that have the same frequency when they're our input when we're actually sorting it, with the key being that function. And so I'm actually going to change this return value of the count indice at that number to be a tuple, and I'll pass in another value or another operation on our number to actually accurately sort and account for ties as well. So after I sort it by the count at that indice number, or basically the number's frequency in the counter, I'm actually going to pass in another operation and say negative n. And what this does is it basically returns or sorts every single number in the input array nums by the count at that indice number, or basically by its frequency. But if we actually get a tie between two or more numbers with the same frequency, we're going to move on to the next operation or the next sorting method, which is basically going to be negative n. And the reason why we do negative n is because we know that we have to sort elements with the same frequency in descending order. And so if we were to just pass in n, for example, let's just take example 3, for example, because it has the most number of ties. When we have 5 and negative 1, when we're sorting by n, negative 1 would come first because it has a lower value. So we actually have to take negative n to accurately sort it in descending order rather than ascending order. So in this case, if we had 5 and negative 1 in this iteration while we're sorting nums, we know that, hey, 5 and negative 1 both have a frequency of 1. Right? If we were to get the counter here, or look at count at indice 5 and count at indice negative 1, they'd both be mapped to 1 because they both have a frequency of 1. And since 1 is equal to 1, we're going to move on to the next operation to accurately compare these two numbers that have the same frequency. And so negative 5, or negative applied to the 5 is of course just going to be negative 5, and negative 1 is going to be 1. And since 1 is larger than negative 5, 1 would actually come first or before the negative 5 in the sorted version. So we'd actually put negative 1 to be before 5. Okay? So now that we'd actually put 5 to be before negative 1. Sorry, that's my mistake. So essentially, now this would actually work. So if we were to submit this, as you can see, this is actually, this should be number rather than n. Sorry about that, guys. But yeah, as you can see now, this would actually work. But again, this is still kind of hard to visualize. So let's just go back to this example 3 so I can explain it a little bit better. So we're going to be sorting this input array nums, right? And let's just say in this iteration, we're going to be looking at 5 and negative 1. 5 and negative 1 are both mapped to 1 in our counter because they both have a frequency of 1. Okay? Since they both have a frequency of 1, or basically count at indice 5 is equal to count at indice negative 1, the next best thing that we can do is move on to this next operation, which is basically looking at the negative version of these two numbers that have a tie. The negative of 5 is going to be equal to negative 5, and the negative of negative 1 is going to be equal to 1. Since negative 5 is less than 1, this 5 would come first because it has a lower value, and so it would be in the beginning or left side of our array compared to the negative 1. And we do this for, of course, 4 and negative 6 as well. Negative of 4 is equal to negative 4, and negative of negative 6 is equal to 6. Since, of course, negative 4 is less than 6, 4 would come first before negative 6. Essentially, the smaller values in that operation as such would come first. But since we're actually comparing the negative, that would actually make it from ascending to descending order, so the larger values would come first, which is essentially what the problem is asking. Okay? So when we're using this nums.sort method, just keep in mind that when we actually pass in a key, it's basically going to sort it by the return value if we actually pass in a function, or basically by that specific arrangement of numbers that we specify in the key. Okay? That's also really important for this problem, because if we didn't actually pass in a key, the nums.sort method would just be defaulted to sorting every single element in ascending order, which is of course what we don't want. We want it to be sorted in increasing frequency. So again, honestly, I think there should be a medium problem, right? And especially if you're solving this in like Java or C++, you're not going to get this simple, sweet, nice syntax as you do in Python. And so it's going to be a lot harder to actually implement your solution. But yeah, that's basically how this problem goes. And if you guys enjoy this solution and learn something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.